Hey guys, hope you're all doing good. In this video, we are going to be learning how to do curve fit with Matlab. Curve fits are really useful as they help you describe how your data changes mathematically. And once you have a curve fit, you can actually do additional mathematical operations which might not be possible in the initial data set. As an example, let us take population data in a particular country, right? There is no known formula that can actually tell you what's the population of a particular country going to be in the next year. However, if you actually do a curve fit, you will basically get a mathematical function which says how the population is going to change as a function of time. In other words, you can put in a future time and predict what the population is going to be. Now, based upon the accuracy of your curve fit, this final result is going to change, but even then with a curve fit you can actually get some rough trends, and since the curve fit is basically a mathematical function, you can do additional operations such as take derivatives and so on. Alright, so in this video I'm going to take specific data for oxygen as a function of time. I'm going to first plot this information and then we are going to basically see if we can fit a curve to it. Alright, so I've already opened up Matlab and I have this particular file called data. This file has been shared with you. This file contains two columns. Let's take a look at it. Right, so the first column is temperature and the second column is specific heat. Now make sure that this file is present in the same directory as your program. So in the command window, I'm just going to type in pwd to make sure that I'm in the right path. And then in the editor, I'm going to start with clear all, close all, and clc, the usual commands. And the first thing I want to do is I want to load the data set. Now the nice thing about Matlab is I can just use the load command, which is an inbuilt command that is used for reading files. And the file that I'm going to read is data. And I'm going to take this and I'm going to store the results in a variable called cp data. Let's put a semicolon, execute. You can see that the program ran and I have cp data which has 3200 rows and 2 columns. So that's perfect. So what I can do next is I can just say that temperature is nothing but cp data, but it's going to be the first column of the cp data, and cp is nothing but the second column of cp data. Right, so let's just execute it, make sure it works, and you can now see that cp and temperature are column matrices. So this is if I have to put a comment here, this is basically preparing the data, and what I need to do now is plot it. So I can just type in plot temperature comma cp. Let's use a line width parameter, maybe give it a line width of 3, and give it some x label. X label is going to be temperature in Kelvin actually, and y label is going to be specific heat with units of kilojoules per kilomole Kelvin. Alright, so I think I got it correct. So let's execute this guy, and there we go. So you can see that this is the variation of cp as a function of temperature. On a separate note, undergraduate students, especially people who are working with air standard cycles, you treat that cp as a constant, right? It's actually not. You can see that cp varies quite a bit as a function of temperature. This is really important. Now since air standard cycle is a simplified cycle, we don't consider this variation, but in real life cp actually varies as a function of temperature and also with respect to pressure in certain cases. So now that I've plotted it, I need to fit a curve, correct? Because I have the data set, but I don't know the mathematical nature of this data. So this is where we are going to use curve fit. The idea behind curve fit is quite simple. You can assume that the function is either a quadratic function or a cubic function or an nth order polynomial, doesn't matter. So I can just say that my arbitrary function f is ax square plus bx plus c. I'm going to say that if I take this particular function, in fact let me just write that down on screen. I'm going to say that cp is a times temperature square plus b times temperature plus c. My job is to figure out what is the best value for a and b so that I can use this particular formula to closely represent my data. So this is actually quite interesting. So to determine a and b, you need two equations, right? So what you can do is, in your temperature curve, you can take 2 points, right? For example, when temperature is 300, you know the value for cp, and when the temperature is 1000, you know the value for cp. You can use these two data sets and figure out the value for a and b. correct? That is going to be a very simple curve fit. But a more robust curve fit is to pick the A and B values in such a way that the error that you get between your original data set and your fitted data set is minimum. All right, and that is the power of curve fit. And in Matlab, you can do it using something called as the polyfit command. So if you type in poly, and if you hit the tab key, and if you type in F, it's going to show you polyfit. And if you open parenthesis, it's going to tell you what are the required inputs. It's going to take the X value, which is temperature, and Y value, which is nothing but CP, and it's going to ask me for the order of polynomial. So I'm going to just type in 2. So that's going to be a quadratic equation. And this is going to give me a set of coefficients A, B, and C. So I'm just going to call this as coefficients. All right. So let's just execute this guy. You can see that I'm getting these 3 numbers, right? So these 3 numbers are basically the coefficient of my polynomial. Now I can use these coefficients and I can actually predict the value for CP, right? So what I can do is I can say that predicted CP is nothing but polyval, right? So polyval is basically polynomial value, and the inputs that it requires is first the polynomial coefficients, which is this guy, followed by the X data set, which is nothing but temperature, right? So if I execute this, you can see that it prints a whole bunch of numbers, and this is my predicted CP. So let me just put semicolon here and here, and what I'm going to do is I'm just going to compare my curve fit with the original data. And what I can do is I can just type in hold on, and I can type in temperature, comma, instead of CP I can just type in predicted CP, and let's add in a line width parameter of 3, and also a color of R, right, so that it's red in color. And just for completeness, I'm just going to maybe take these 3 guys, cut it, and then paste it here so that the code looks more organized. And we can just delete these guys and clean up the code a little bit. Something like this would do. Okay, so it's always good to add labels after you have made the plot. So maybe moving it here, that would be a good idea. So now if I execute this code, there you go. Now I need to put the legend to make sure that I can distinguish my original data set and my curve fit. Hit F5 again. There we go. So we have a plot. So what can you say about the curve fit? Well, clearly it is trying to match our original data set, but it does not do a good job, right? So maybe I can increase the order of my polynomial, and what I can do is I can just change this guy to 3, hit F5, right? And almost immediately you can see that it tries to do a much better job, but I'm getting some warnings saying that the polynomial is badly conditioned, which is not good. But visually you can see that the data set seems to be much more well represented, right? So what you are going to be doing as part of your challenge is you're basically going to figure out a better way to fit the data. There are a couple of ways to do this. You can try out different polynomial orders. You can also use splitwise polynomials, meaning you can use one polynomial for one temperature range and another polynomial for a different temperature range, right? But try it out and also try to come up with a way to measure the error in the solution. There is a nice way to do it, but I want you guys to figure it out. So do some reading about how to determine if a curve fit is good or not, and try to code in that particular condition to see if your curve fit is good or bad. Okay. All right. So with that, I would like to conclude this video, and I'll see you guys in the next video. Bye.